Hi, scholars! Today we are going to learn about mathematical statements. We will be dealing with conditional, converse, inverse, contrapositive, and biconditional statements. We will write negations and recognize logically equivalent statements. And lastly, we will formulate biconditional statements from definitions. Before we start, I want you to examine these three statements here. You might have seen the first one on the Scratch software. This is a command that says that when the green flag is clicked, then the start game command is broadcast. The second one came from a meme which says that if you look back, then you become some random person's person. The third one came from our national hero, Dr. Jose Rizal. He said that if you don't know your own language, then you are worse than an animal and a rotten fish. Now, I'll give you a minute to think of what's common with these three statements. So, did you notice what's common among the three? Well, you're right if you've noticed that all statements have a condition that must be satisfied before a consequent event can happen. In the first example, if the green flag is clicked, then the game would start. In the second, if you look back, then you would be someone's person. And in the third, if you do not love your own language, then you become worse than an animal and a rotten fish. These if and then statements are what we call conditional statements in mathematics. Mathematically defined, a conditional statement is a statement that has two parts, the hypothesis and the conclusion. The hypothesis is the if part and is usually denoted by the capital letter P. Meanwhile, the conclusion is the then part and it is usually denoted by the capital letter Q. When the entire opposite of the statement is stated, then it is called the negation of a statement. Both P and Q can be negated. Let's take note, for example, the statement, if the green flag is clicked, then the game would start. The negation of P, or not P, is if the green flag is not clicked, whereas the negation of Q, or not Q, is then the game would not start. Please take note of the notations not P and not Q. When you interchange P and Q and make it if Q then P, then you are stating the converse of the conditional statement. Let's use our first example again. Our conditional statement was if the green flag is clicked, then the game would start. The converse statement of that would be if the game started, which was originally our Q, then the green flag was clicked, which was originally our P. Again, with respect to the conditional statement, the converse would be in the form if Q, then P. Now, what if you negate both P and Q, such as in this example? Originally, our statement was if the green flag is clicked, then the game would start. If we negate P, then it becomes if the green flag is not clicked, and if we negate Q, it becomes then the game would not start. This form, when we put them together, is what we call the inverse of the conditional statement. This is again in the form if not P, then not Q. When you interchange not P and not Q, and you have if not Q, then not P, you call that the contrapositive of the statement. For example, if we change our conditional statement into if the game did not start, then the green flag was not clicked, then that is the contrapositive of the statement. Again, it comes in the form if not Q, then not P. Before we move to the next section of this lesson, let us have an example. Suppose our conditional statement is, if you are a precise scholar, then you are a diligent person. Our hypothesis is, if you are a precise scholar, and our conclusion is, then you are a diligent person. Interchanging that, we get the converse. If you are a diligent person, then you are a precise scholar. Negating our conditional, we get our inverse. If you are not a precise scholar, then you are not a diligent person. Lastly, we get the contrapositive by getting the converse of the inverse. If you are not a diligent person, then you are not a precise scholar. You probably noticed that not all of these statements are true. That is what we are going to talk about in the next section, about the truth values of our mathematical statements. In a world of rampant misinformation, it is a good quality for us to check the truth or falsity of statements that we encounter every day. These truth or falsity is what we refer to when we say truth value of a statement. Let's say we have the statement 5 times 6 is equal to 30. We all know that it is true. So the truth value of that statement is true, and sometimes we denote it with T. Its negation, 5 times 6 is not equal to 30, has the truth value false, or sometimes we denote it with F. If statements were as simple as the previous examples, it would be easy to determine their truth values. But what if statements were now connected with AND, or, if and then, or if and only if? Now, we call those statements compound statements. There are different types of compound statements, and they are listed for you here with their respective symbols. First, we have the negation, as in what we did in the first example. Second, we have the connector and that is what we call a conjunction. Third, we have the connector or, which makes a disjunction. Fourth, if we have the if and then statement, we have a conditional statement. Lastly, if we have the if and only if connector, then that makes the biconditional statement. For a conjunction to be true, both P and Q or both statements must be true. Otherwise, it would always be false. On the other hand, for a disjunction to be true, we only need at least one of the statements to be true, and the whole statement would already be true. In cases when both statements are false, then the whole statement would be false. Interestingly, the only time that a conditional would be false would be when the hypothesis is true and the conclusion is false. We make a biconditional statement when we combine the conditional and its converse with the connector if and only if. It is only true when both statements are true. We would also like to identify logically equivalent statements. When we say that statements are logically equivalent, we mean that they have the same truth value. That is, they are either both true or both false. If we map out the truth tables, we would find out that a conditional is logically equivalent to its contrapositive. To have some practice on truth values, please refer to SLG 1.2.2.